comprehensive continuation starting Unit 2. Let's look at object-oriented concepts now. So object-oriented programming makes the computer language resemble the way things look in the real world. So if you look around where you're sitting in a room, you will find many different objects, such as a table, a chair, a light, or a computer screen, or a computer itself even. These are all real-world objects. So the programming language such as C++ also will allow you to create objects that will resemble just like a real-world objects. Object-oriented concepts encapsulate real-world objects because they have characteristics and behavior. So if you look around the room for any particular object, such as a chair, which is an object, it has a characteristics and behavior. So now let's look at it. What is the characteristics? Characteristics of the chair is that it is made with something, a wood, or an iron, or a plastic, but it is made for some particular purpose. The purpose of a chair is to sit on it. Of course you can use the chair for many other purposes, but main purpose of the chair is to sit on it. Okay? So that is its behavior. And that's why we call a chair is an object, because it has a characteristics and behavior. Object-oriented languages must satisfy following three criteria. These are data abstraction, inheritance, and polymorphism. Let's look at these three criteria individually, starting with a data abstraction. The combination of data and the operations, which are functions on the data, creates new data type called data abstraction. So basically, to do that, C++ provides a concept of a class, which we talked about earlier, which will create like a miniature program within your C++ source code. Okay. So you can create multiple classes if you want, multiple type of data abstractions within your code. And data abstraction type behave just like a built-in C++ data type, except the programmer defines the type. So what that means is that data abstractions gives you a capability of creating a new data type, okay, similar to a built-in types such as an integer, a float, or a character. But when you create your own data type, that is user-defined data type, by using a class concept, and we will cover that in our course. In most of the examples we will do, it will allow you to understand what the classes are, how to create the objects, and so on. Okay. Let's see the example on the next page to understand what exactly the data abstraction is. So before jumping into understanding what the classes are, as you know, C++ is a superset of C. So C++ allows you to use whatever the keywords that C provides. In this example, I'm using a struct keyword. Okay? And hopefully in your C class you have learned how to create a structure. So structures, the purpose that you create a structure is to identify the one thing by putting all the data at one place. So in this case, notice that I am at starting with line number 1, I am using a keyword struct, and then it has a tag called date. Okay, so I'm basically creating a user-defined data type, similar to a built-in data type such as int or float. Before moving on to the example, let's look at this line number 0. Line number 0 says that include this library, IOStream. Okay, IOStream library is very similar to stdio.h in C. But IOStream library gives you much more bigger variety of functions that you can incorporate within your code. Since it's a library, so all those functions are already pre-existent and they are already written for you. So let's go over this example 1-1 to understand what the data abstraction is. So notice that starting with line number 2, I have the member declared, a month. Okay, that is a data member within this structure. Okay, and I have declared it as a type integer. I use the built-in data type. And then at line number 3, I declared another data member, which is also a int type. And then I also declared at line number 4 a year, which is an int type as well. So up till line number 4, whatever you have done or learned in C language, you can do that exactly the same thing in C. Okay, but what you cannot do in C language is line number 5, meaning that notice that I have a function name within this structure body, which is not allowed in C language. And that's what the difference comes between definition of a structure in C and a definition of a structure in C++. So the structure body ends at line number 6. Please make sure that when you are ending the structure body, you must put in the semicolon. If you don't put in the semicolon, you will get, during the compilation of this code, you will get at least about 100 errors just because you forgot to put in a semicolon in there. So this structure defines a complete definition of an object. Why does it become an object? Why do I call that this structure, when you create an instance of this structure, it will become an object? Why? Because it has a characteristics and a behavior. Okay, so the characteristics are all those data starting from line number 2, 3, and 4. Those are the data because we call them a data member. And at line number 5, that is a member function, which is a behavior. So the definition of an object is that must have a characteristics and a behavior. So when you create an instance of an object, okay, that instance is basically nothing but an object. So within this main function at line number 9, I'm creating an instance of this type, date. Okay, notice that it is unlike C. I do not repeat the keyword struct in front of the date. C++ doesn't require you to have the keyword struct in front of the date, but it behaves basically very similar to it. In C, we would call that a variable of this type, which is date. But in C++, we don't call it a variable because this is actually an object. It's an instance. Okay. In C also you will call an instance of a structure, but the meaning changes between a C and C++. In C++, it becomes an object, like I just told you, because it has a characteristics and behavior. It has a data members and a member function. Okay, so the body of the main is almost similar to C language. It returns an int type. Notice that I don't have to have a return statement in there. Okay. Depending upon what compiler that you're using to compile this code, if you're using a Unix Linux, you do not need to have a return statement. If you are using a Microsoft compiler, it probably will complain. So you may have to put a return at the end of or right after line number 13. Okay. Otherwise, Microsoft compiler is not going to be happy. So let's look at it how once we create an object or instance of type date at line number 9, we actually are allocating the memory. Okay. Where are we allocating the memory? The memory is allocated on the stack. Okay. So the memory is allocated on the stack, and how much memory is going to be allocated? It depends on the size of an integer on your machine. So just to simplify, I would say the size of my integer on my machine is 2 bytes. So basically, when I create this object called hire, I allocate 6 bytes. Now if you wonder, if I allocate 6 bytes, what happens to the memory for the function show? Is the memory allocated for the function within the object? No, there is no memory allocated for the function within the object. And we will go into quite a bit detail about it, because to understand that, you will really need to have a good understanding of pointers. Okay, so we will discuss one of the examples in chapter number 2. Why the memory is not allocated for the behaviors or the functions within the object. So let's look at what is happening at line number 10. At line number 10, since month is a data member of a structure, which is a date, I have to use a dot operator, and I hope that you know what the dot operator is. Dot operator allows us to have access to the members of a structure. So to have that access, I first must have the memory allocated. Okay, and that's why at line number 9 we allocated the memory for that particular object. So now at line number 10, I'm accessing that particular memory, which is the label of that memory is m_month. Okay, so hire.m_month. So now that will allow me to access that particular memory and assign anything that I want. In this case, of course, integer values. So because m_month is an integer type, so I'm assigning or hard coding the data on that memory. Okay, so I'm assigning month 3. Similarly, at line number 11, I am using an object which is a higher dot m underscore day, which is a data member of a structure called date, and assigning 14 to it. Okay, and I'm doing the same thing at line number 12, assigning 80 to m underscore year, which memory is already allocated when the object was created. You can't utilize the memory if you don't first allocate it. Okay, so where is this memory going to be allocated? At line number 9. This memory is going to be allocated on a stack, on the stack. Okay, so when you allocate this memory, some of the stack memory will be gone. Okay, it's not on the heap, which on the heap we'll discuss it later in chapter number 2. The memory comes from the by using in C++ allows you to have a different dynamic way to allocate the memory by using a different operators, okay, which is called a new operator. So we will do that in chapter number 2. But once the memory is allocated, it will go out of the scope, meaning the memory will be released, okay, after line number 13. Then this object is no longer going to be in the memory. So the memory on the stack is basically automatically released once the object goes out of the scope. So let's look at it, what is happening at line number 13. At line number 13, I am using a higher object to call the show function by using a dot operator. Okay, so whenever the body of the show function, we will go over that in a minute, but the body of the function is outside the structure. Okay, at line number 5 that we just discussed, it is just like a function prototyping. So at line number 13, the call to the function will occur. Okay, when the call to the function occurs, this function, since it's a member of the same structure where the data is there, okay, so it can see all the assigned values on that memory that we have, and it will be able to display all that on the screen. So let's look at the body of a show function. First of all, at line number 16, as you notice that it's just a comment, 2 forward slashes that will start the comment, okay, till the end of the line. At line number 17, the body of a show function starts. So the body of a show function is quite a bit different. The starting is quite a bit different than you would do it simply in C language. In this case, the way that it is declared is that very first thing that you see is the void. Okay? Void is a type, return type. So if I don't put a void, by default in C++, it is int. Now, as I told you earlier about the main function, in Microsoft, it may not be an int. Okay, so you have to understand that by default in Unix, Linux, the return values of our functions, okay, so our function like a main or a show function will, by default, it always be a integer type, unless you say it that what type it is. So in this case, I'm just saying void, meaning it doesn't return any value. Okay. So if I, at line number 7, if I wouldn't have put anything in there, it by default it is, if I wouldn't have put in int, by default it still would be an int. At line number 17, I'm making sure that the return value of a show function is a void. Right after the void is a date. Okay. As you can see, the date is the name of our structure. Okay, struct that we created earlier. So that is the name of a structure, where the show function is in the body of it. So the show function is a member of a structure called date. So you see those two colon, those two colon are called scope resolution operator. What is it? Scope resolution operator. So the compiler is notified that the show function is a member of a date struct. So when you're doing the compilation, that's why you would not see any errors. Okay, compiler must be told who is this? Where does this function belong to? Which struct or a class this function belong to? Because you can have a multiple names of a function, same name of a function, but they belong to a different classes or a different struct within the same piece of code base. Okay, so that's why it is very important to let the compiler know which class or a structure that show function belongs to, or it is a member of. So now notice that the functions start and end. So curly braces, left curly braces will start the function, right curly braces will end the function. Okay, so that's just like a C language. But notice that at line number 19, there are some new things in there because of the C language, C++ language. And we will discuss this more in the next few slides, but I will just go over very quickly here. The first STD that you see at line number 19, it is basically the C++ provides a standard class libraries. Okay, and that's what it stands for. And right after colon, what is the colon? It's the same thing as we discussed earlier. It's a scope resolution operator. And then the Cout. Cout is an object already declared by the compiler. When you install the compiler, it is already declared. We will go into more detail in the next examples. And then as you notice that left shift operator, okay, that is basically it's really not used as a left shift operator in this regard right here. It is just telling right now that whatever the values stored in that memory location, which is m_month, give it to this object, okay, Cout object, and it will print. So it is, notice that it is all cascading, you know, and then right after the m_month, there is another left shift operator. Okay, it tells the I'm giving a in a double quote / it will just print that. Similarly, m_month day and another slash and another data m_year will be printed. Okay, so the output will look like 3/14 and then 80. So whatever the data that I initialize, that data will be printed because I made the call at line number 13. A show function was called, okay, within the body of a main. So this is quite a bit different than what you have seen it in C language. In C language, to do the printing or displaying of the data, you will use a printf function. So please, you need to understand, do not use a printf functions in your C++ programming. Okay, so the assignments that I will give it to you, I would expect that there won't be any C related code, but since we are using the object-oriented language, so we should be able to capitalize fully on it. So if you would use a printf function, for example, printf function, you have to tell what data type is. So format specifier like %d or %f or %s, so forth. You have to, those are format specifiers in C language, but you don't have to do any of that here in C++ because the Cout object is smart enough to know what data type it is. Of course, this is too early for you to understand how is it smart enough to know, but soon in like lecture number 4 or chapter number 4 and 5, you will start understanding how this object is defined and how this object has a capability of understanding that this memory that is about to print is either a float type or an integer type or a character type, because the Cout object, as I said, is pretty smart to understand how to do the printing. On the other hand, in C language, you use a printf, and it is all up to you to make sure that you put a proper format specifier within the printf. So let's look at it, inheritance now. This is a basic overview of inheritance. We will go far more detail about inheritance in chapter 7. Okay, so please understand, this is a very quick example about inheritance, just to give you a very high level overview of inheritance, how it is designed to work with C++ language. So source code is organized in a hierarchical ordering. So when you write a code in C++, you first have to come up with multiple classes, and your job will be to separate out and create a dependencies between the classes. So hierarchical ordering is designed using a class concept, and that's how you will make one class inherit the other class, meaning you will create the concept of a parent and the child class, okay, or a base and the subclass. So each class completely represents a single concept. So you can basically work with a single class, or if the class is derived or you have a child class, okay, then you will get whatever the child class has plus whatever the parent class has. Okay, so what I'm talking about is if a child and a parent class both have some sort of a data, and when you create an object of, or when you create an instance, just like the instance that we did in the previous example, a hire, if you create an instance of some child class, you, in that instance, you will have the object of type child class as well as the object of type base classes. Okay, we will go into much more detail, as I told you, in chapter number 7. So you specify the relationship between a parent, which is a base class, and a child, which is a subclass. So that is up to you how you put together these relationships. Of course, if you didn't put them together properly, then you could run into lots of different issues within your source code. Okay, so the very first thing to do is to create a nice little diagram, not too much detail, but have a concept in your mind that you will easily be able to inherit one class from another. Now, in some cases, you may not need to inherit, so the class will be independent. Or in some cases, you may have a two different tree. So this is basically what you see, the hierarchy. Hierarchy is nothing but a upside down tree. Okay. So in this case, we have, in this example, we have a base class called vehicle. Okay, and I derived from the vehicle class, at next level, I derived a bus class, a truck class, and a car. Why? Because vehicle is very generic term. That's why we put it into the base. Okay, so bus class really will have quite a few differences between a car or a truck, but at the same time, truck and a bus class might have a similar things, you know. Remember, whenever you are putting a class together, you are your object will look like that. So you are within the class, you are defining how your object is going to look like. So the car doesn't really drive the same way as the bus. Bus have many more gears. Car doesn't have that many gears, you know. Car can go really fast, bus doesn't go that fast, and so forth. So there are quite a few differences, and of course the sizes are different and so forth. So we will go into inheritance much more detail in chapter number 7. Let's look at what the polymorphism means. Multiple implementation, single interface. Basically what it means is that you have a multiple bodies of a function. Okay? And all of those functions have a same name. Now, you can put this same concept, multiple bodies of the function in one individual class with there are some restrictions that we will talk about it, that is called function overloading. We will go over in quite a bit detail later on. But or you can put the multiple different bodies of a function in a separate class with the same function name. So looking at the hierarchy in the previous page, I can have the function added to all of these classes, a function such as a drive. Okay, because this is we're talking about a vehicle. Every vehicle must be drivable, so every vehicle will have a drive function. Okay, so that means what I'm doing right here is having drive function body in every class, okay, in a bus class, a truck, and a car, but it will be a little bit different for every class. You know, vehicle, the bus doesn't drive the same way as a car does, or the truck. So the definition of the function itself will not be the same. Okay, so the point right here that I'm trying to make is
you can create a multiple bodies, multiple implementation of a single interface. Okay, that's what one thing about the polymorphism is. So it allows a single operation, which is a method or a function, to behave differently with each object. How does it do that? So taking the example of a drive. So in this case, as I say right here, operation drive may be defined to move a car from one location to another. Okay, same operation drive can be used to move the truck, okay, from one location to another. So now, how is that going to happen? It happens because you are going to be working on a particular object. Okay, so whichever the object that you're working with, if you're working with a car object, then the method or function drive will be called from the car class. If you're working on a truck object, the method or a function will be called from a truck class. So about polymorphism, we will go into quite a bit detail about the polymorphism in chapter number 8. Okay, but to understand polymorphism, you will have to understand the inheritance, because without inheritance, you would not really know what the polymorphism is, how it has been used. So the polymorphism that we will discuss in this class is two different types of polymorphism. One is a compile time polymorphism, and the other one is a runtime polymorphism. Okay? So the runtime polymorphism is done with the concept of virtual functions, and compile time polymorphism is done with the function overloading. And we will go into both of these quite a bit detail later on. First with the function overloading, and then in chapter number 8 runtime polymorphism. So basically, polymorphism simplifies the syntax for performing the same task differently based on the type of an object. And that's why I was giving you the example. Depending upon which object that you work with, because if you are working with a car class object, then the drive function will be called from the car. Okay, if you're working with a truck, then it will be from the truck class. Okay, so this is an end of unit 2, and the next we will start is unit 3.